I am Rashmi. I am a data scientist from Silan Software. Today I will start a series on machine learning algorithms. So our first algorithm goes by this: linear regression. So why it is termed as regression? So you know it is a supervised machine learning algorithm. So under supervised machine learning algorithm, we have two kinds, that is regression and classification. So linear regression is a part of regression algorithms. Linear regression. We also have multiple linear regression, and polynomial regression. So today I have choose the topic of linear regression. So let's start. Let me take a data set on ice cream sales. So this is my data set: temperature in degrees Celsius and sales. Suppose there are some data here by considering the rows. Suppose 18 degrees Celsius. Suppose sales is around 30k. Suppose there is 30 degrees Celsius. Sales is around 40k. And suppose there is 45 degrees Celsius. So sales will be higher. In summer seasons, you will see that temperature, with increase of temperature, people like to eat ice cream. So suppose 45k. So there are lots of data like this. So if I will draw a graph for this one, let it be a scatter plot. This will go by this. So these are the points. Okay, here is sales and here is the temperature. So you can see here we can draw a line. So how will draw a line? I can draw like this, I can draw like this, I can draw like this. So these are all the lines you can draw. But what linear regression suggests is there is a best fit line which is equidistant from the points, data points, which is equidistant from the data points. So this is called our best fit line. And the equation goes by this: y equals to mx plus c, where x is the temperature and y is the sales. So let's deep dive into the topic with our program in Anaconda environment. So as we have discussed, y equals to mx plus c. So what y stands for? Y stands for sales, x stands for temperature, and m stands here for slope. What is the slope of the line? And c stands for intercept. So what is slope and intercept? How to know that? Now in a graph, if a line travels like this, which is the best fit line, for the points here, 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 here. So why it is called the best fit line? Because as the line traverses, the points are in equidistance from these points, this distance. So distance is optimized. After optimization, distance is optimized. So after optimization, we get the best fit line. So this is called the intercept. And this is called the M, which is the slope. Okay, so let's dive into the programming concept. So I have already inputted all the necessary libraries, which is pandas, numpy, cbun and matplotlib. Next, I have given the address of the file ice cream sales.xlsx, and which is invoked by read excel function from pandas. Okay, now I will display the data. So this is our data, temperature and sales. Now I will say what is the shape of my data. df dot shape. The shape is there are 12 rows and 2 columns. Okay. Now df dot info. df dot info gives if there is some null values, so it will display, but there are no null values present in the dataset. Next, df dot describe. df dot describe gives some handful of statistical information. Okay, what is the output? Now this is the output. If I will give the count as 12 column rows are there, 12 rows of cells are there, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile and maximum. So we can draw a box plot to represent these 5 values. We can represent this in a box plot. So how to do this in box plot? This is called 5-point summary. I will give it as box plot to represent 5-point summary. Okay, what is the 5-point summary here? The first is minimum, comma 25 percentile, comma 50th percentile, which is also called median, comma 75 percentile, and then is the maximum value. How to represent this in a box plot? The SNS dot box plot df dot temperature. So this is the box plot. So see here, what is the minimum value? 11.9, which is around 12. So this is around 12. What is the 25 percentile? 16.1. This is 16.1 value. Next is 50th percentile, 18.3, which is the median of the box plot. This is the median of the temperature values. Then 22.22. So this is the value here. Next is maximum value 25.1. 25.1 lies here. This is the 5-point summary of the box plot. Okay. Next graph is the distribution plot. SNS dot dist plot df dot temperature. So this is the distribution plot. You can see here from 15 to 20 there is a rise in values. So 15 to 20 temperature, there was the cells value, the temperature value was too high in the density. In the here if you see from 15 to 20 there are lots of points here. So density of the points from 15 to 20 was quite high. Okay, 15 to 20 there was more number of points are there, data points are there. Next is splitting the data set into independent and dependent variables. How to do this one? The x equals to df temperature and y equals to df cells. If I am right, then it will run. Okay, it's right. Temperature column and cells column. Next, you have to do the trend test split. Trend test split. So how to do this one? Now from scalar dot model selection input trend test split. Now it's trend. So actually the trend test split function returns 4 arrays which are xtrend, comma xtest, comma ytrend, comma ytest equals to trend test split x comma y comma test size equals to 0.25 comma random state equals to 101. Okay, trend test split the performance have been done. Now I will input the algorithm, that is simple linear regression algorithm implementation. How to implement? From scalar dot linear model import linear regression. Okay, model equals to, since linear regression is a class, so how to call a class? So how to call a class is that object equals to class name and parenthesis. This is also run. Now I will do model training. How to do model training? The model dot fit x train comma y train. So model training has been done. Now I'll predict the y values for our x test values. Y prediction equals to model dot predict x test. Okay. Next, for the accuracy score, model evaluation. Which is from sklearn dot matrix import accuracy score. It can be accuracy score or R2 score. Sorry, for regression problems we need to define R2 score. So R2 score y test comma y grade. So the accuracy score or R2 score is 97%. If we turn it to it like this into 100, it will give the 97.47 percentage. Okay. This is the way linear regression is being performed. For more videos, subscribe to our channel